Imagine you made a bar graph of the height of the entire population. It would be a curve shaped like this, also called the normal curve. You have a small amount of people who are very short, a small amount of people who are very tall, and large numbers of people who are about average height. In this curve, the highest point, or the kurtosis, is very high, and you have very skinny tails. Imagine you couldn't get the height of everyone in the entire population. You only know the height of everyone in your classroom. In that case, the number of people in the room would be the sample size. And when you only have the sample size, you don't know the mean or the standard deviation of the population, so you try to make inferences about the population from the data that you have on your sample. In this case, you will produce a t-distribution. In this t-distribution, your kurtosis is lower and you have fatter tails. You can have t-distributions of different size based on the size of your sample. This measurement is called a degree of freedom, and it equals your sample size minus 1. So let's say you only have a sample size of 2 people. You will have 1 degree of freedom, and your curve will resemble something like this. It will have a very low kurtosis and very fat tails. If your sample size gets a little bigger, let's say you have a sample size of 11, thus you have 10 degrees of freedom. Your curve resembles the middle one. You have a slightly higher kurtosis and skinnier tails. As your sample size continually gets bigger, your curve starts to resemble the normal shape.